Okay, now that we have the firmware updated in the ECU, what we need to do is modify the tune for the modifications done to the vehicle. Now, a single set of long tube headers is a modification that does change airflow requirements, but it's not a major mod. It's going to affect air fuel ratio in a few key places. We're probably going to make more torque across the board. However, that's a minor tuning thing. The 52-pound injectors we did put in are a significant upgrade over the stock injectors. So this tune is currently set up for 19-pound injectors, so 52 is more than double the injector. Let's go over those settings, and then we're going to take a look at some of the other the fuel and ignition tables, and I'll talk about what you should do if your vehicle is modified with, say, boost. So engine and basic load, engine and sequential. Right here we're looking at required fuel. Now this engine is currently tuned on mass air. I'll change it over to a speed density tune when we're doing some idle stuff so you can see the differences. So we're going to go into required fuel, and you can see it's currently set for 19-pound injectors. We're going to go ahead and set this to 52. We're going to hit OK. You'll notice the required fuel changed. The required fuel acts like a scaler, okay? Your VE1 table here. Now, of course, this table looks different because it is a mass airflow table. This does not equate directly to a speed density table. So don't mind the numbers here. This is, again, mass air works completely different from speed density. The required fuel is a modifier in a speed density tune. So if this was a speed density tune, what we would see is we could manipulate the required fuel to manipulate the VE table. But we really shouldn't. We should always put in the correct injector settings in our required fuel and the correct injector settings in our injector dead times. And here's the reason why. The VE table is supposed to be a cylinder fill table. Your engine consumes a certain amount of air per engine cycle. And when we talk about the air fuel ratio, the stoichiometric ratio of fuel for gasoline, we say, well, gasoline AFR or lambda 1 is 14.7 parts air to 1 part fuel. That means that if we are consuming, say, to make math easy, if we're consuming 14.7 cc's of air a second, we're going to need 1 cc of fuel a second to be at lambda 1, or an air fuel ratio of 14.7. So your cylinder fill table is a percentage of that. If your VE table says 50, right? If this here was 50 and you were idling at 50, that means that right here at these points, you are essentially filling the cylinder 50% of its volume, which your VE at idle should probably be somewhere between 25 and 45 for most motors. It really depends on the engine, the camshaft. There's a lot of things that go into, how efficient the motor is. For that, that's a completely different topic. So if the VE table is a cylinder fill table, we can see how things directly correlate. At naturally aspirated, wide open throttle, you should be somewhere around 100 in your cylinder fill table. Why? Well, I mean, can you fill the cylinder more than 100%? Some very, an engine like a Coyote, that's possible. Race motors with very aggressive camshafts, or specific engine setups with efficient cylinder heads, efficient camshaft design, exhaust, in certain parts of the RPM range where scavenging is happening, it is very possible to fill the cylinder more than 100%. In a boosted application, it's quite easy to fill the cylinder more than 100% because you are you're applying an artificial atmosphere. So if you think of the VE table as a cylinder fill table rather than just bigger numbers equals more fuel, it helps you get an idea of what the engine is actually doing in the state that it's in. That's about the easiest way I can think of to cover that topic. If you want me to go more in depth with that, I can. But at the end of the day, if cylinder fill percentage is confusing to you, then you're not wrong to say bigger number, more fuel. That totally works, and just go along with that. Now, one thing that's important to note here in general settings, we've got this incorporate AFR target. If this is off and you don't include AFR target, your VE table is just a fuel table. Bigger numbers, more fuel. It's not going to equate to cylinder fill percentage whatsoever. I always include AFR target. I do that because I like to look at the VE table as a cylinder fill table, and that lets me know that injector settings are correct if at naturally aspirated wide open throttle on a head cam intake motor is somewhere around 100% or 105, somewhere around there. I know that's a real number, and a production engine, generally the OEMs are going to leave some performance on the table for emissions reasons, or whatever choices they made. It's not unheard of to have a maximum VE value on a pedestrian vehicle that only reaches 85 or 90 because especially if it does not have a performance camshaft in it. That's pretty standard. All right, moving on. So our required fuel is set, and now what we need to do is update our injector dead times. Our injector dead times are right here under fuel settings. Now we are looking at the 1.6 firmware, and the voltage curve is done in microseconds, okay? Not milliseconds, microseconds. So that means we're going to take milliseconds and we're going to add, we're going to multiply milliseconds. So on our support page, we've got a write-up on this that covers exactly how to do it. If you go to DIYAutotune.com, go to support, it's update injector dead times for firmware 1.6, and you'll not only is there a full write-up on it, but there's also a nice spreadsheet that you can use. Now you will have to have some data for your injectors for the spreadsheet to work. These injectors are Bosch 52s. However, they're from Ford Racing, so it's a MU52 injector. So I go to the Ford Racing website, I grab that data, and I put it into our spreadsheet. Here on our spreadsheet, we've got a tab called Ford Data Conversion. This is available to you when you download the spreadsheet from the website, and you will put in your offset data and your offset compensation data, set your base fuel pressure, and it will spit out injector dead time settings, not only for firmware 1.5, but it's going to spit out data for firmware version 1.6. You can use, in 1.6, a big change is that you can either use a dead time curve or you can use a dead time table. A dead time table is really effective if you've got a vehicle that has fuel pressure input. You can use a voltage versus pressure table, and to do that, what you're going to do is come over here to generic sensor inputs. You'll set yourself up a fuel pressure sensor, and it's got to be scaled in kPa, not in PSI. It must be scaled in kPa. And then you'll come down here to fuel pump and pressure, and you will set your pressure sensor input. Notice how it says kPa. If we click the tooltip here, it says you must use kPa in generic sensors. So to convert from PSI, we'll multiply by 6.9. So 100 PSI is 690 kPa. So you'll set your pressure sensor up in kPa, input it, toss it in here. I'm just going to choose a sensor so we can look at the value. And the sensor type matters. If you're using a typical like low dollar motorsports pressure sensor on a return style regulator, you're going to choose gauge because it's a gauge sensor. If you've got a 4.6 Ford and you're using the factory fuel pressure sensor on the fuel rail, that is going to be a differential sensor. Differential means that you know, it's going to be reading the difference between the fuel rail pressure and manifold pressure. So it'll have a vacuum line that runs from the fuel pressure sensor to the manifold. It's very important that you set your sensor up appropriately. If you don't, you're going to get the wrong pressure input reading to the ECU, and it's going to throw off the value. Just to cover it, an absolute sensor, okay, means that it is scaled off of the closest we can get to a perfect vacuum on planet Earth, right? To get to it's impossible to get to a perfect vacuum inside an atmosphere, but they do pretty well. What this means is that your absolute pressure sensor will read somewhere around barometric pressure when you have no pressure on the rail. So if you had disconnected the sensor from the rail, it's going to read somewhere around 14.68 to 14.7 psi, which is 1 atmosphere, which is 100 kPa. That's the air you're breathing right now. All right, so I'm going to shut this back off because I do not have a fuel pressure sensor coming into this vehicle. I'm going to set this back to voltage curve because that's all that's applicable. And what I'm going to do now is I'm going to hop onto the web. I'm going to find the data I need, and then we will toss it into the spreadsheet and calculate that. All right. So these are Ford Racing MU52s. You see I am on performanceparts.ford.com, and the last value there is MU52 right here. I know a lot of you Mustang guys like to use these Ford Racing injectors. So we're going to scroll on down, and we have these summaries here, right? So MU52, we can see to convert to a delta of 45, multiply your flow rate, because all these injectors are actually quoted at 39.15 psi versus your 43.5. So we're going to grab the MU52 calibration summary and bring that up. And the two values that we're going to focus on, okay, is this offset. Notice that says voltage versus offset in milliseconds. So we care about this data here, and we care about this off compensation data. Okay, so the off compensation, basically this is the pulse width offset compensation by pressure. Notice when the pressure is lower, the compensation is lower. When the pressure is higher, the compensation is higher. Same for your offset. As voltage increases, your offset decreases because the injector will open faster. One thing to note is that this minimum pulse width is 0.73, okay? That means that if we are looking at our pulse width within TunerStudio and we see that we are near 0.75 and we're starting to get lower, like this happens, it's pretty common for this to happen on a very large injector on a small displacement motor. Usually I don't worry about this until we get into the 140, 200 pound injector range, that I worry about small pulse widths. Once we start hitting that minimum pulse width, that means that the injector is no longer in the linear range, okay? When the injector leaves the linear range, then we need some offsets, okay? That data I do not calculate from this sheet. So if you're using something like fuel injector clinic injectors, They still do the injector data in the 1.5 values, but you can import that data over, and the small pulse width section there is still correct in the 1.6 firmware. So again, you know, small injector pulse widths only really matters when you're using a very large injector on pump gas or race gas on a small displacement motor. All right, so let's go ahead and take this data and put it into our spreadsheet. What I've done here is I've thrown the spreadsheet up on one side and the injector data up on the other. And I'm just going to go through and I'm going to set this. Now, I only really care personally about as low as 8 volts. If your battery voltage is dropping below 9 when you're cranking, you need to take a look at your battery. So I'm going to go 8. And all I'm going to do is I'm going to grab the value right here from this sheet. Okay, and I'm going to punch in 3.084. I hit tab. I'm going to move on to the 11 volt section, 1.505. All right, so I got my battery voltage offset punched in. Now I'm going to come over here to my my fuel pressure offset compensation. And the last set of injectors I used this sheet for, I went up to 125 pounds. So this data only gives me up to 60 psi. So that's what I'm going to do. I'm going to do 30. Looks like we've got 39.15. We've got 44.95. 50.03, 54.96, and finally 60.03. These very small numbers, you could probably do some rounding here if you're, you want to move through it quickly. I like to just be exact. All right, and it has done all the calculations for us. The last thing we need to do is set our base fuel pressure. And the base fuel pressure on this car is 43 psi. And there we go. Now, if you're still in that older 1.5 firmware, here's the values you need to input into the software. For those of us who are in 1.6, here we are. Here's your curve. And here's your entire table if you want to input that data into your table. Now, something interesting to note, and a lot of injectors actually do this, especially the Ford injectors. Notice how after 55 psi, the offset compensation slope for this particular injector actually drops off, right? So we increased to 1.21, and then we dropped down to 1.16. And that's why in our fuel pressure voltage offset table here, you'll notice the numbers climb, and then they get lower. Okay, and this is important because if you're just using a curve and you're not compensating, it could be an issue. Something to note, however, if you've got a return style fuel system and you have a vacuum referenced fuel pressure regulator, as boost pressure goes up, of course, fuel pressure is going to go up, but you have a delta. You're always going to maintain that delta pressure across the fuel injector. The ECU is going to do all those calculations, and it's going to pull the appropriate dead time from the table. All right. And the only thing left to do now is to take this data and put it in the ECU. So what I've done is I've replaced the data sheet with the software here. Now we're going to go to fuel. I'm going to pull up our injector dead times. And I'm going to leave it on curve, and I'm going to take this data and I'm going to put it right there. Now, let's see if it will let me cut and paste. Hey, look at that. Okay, so that made it easy. I was able to cut the data or copy the data right from the spreadsheet and drop it directly into the software. And we are done. Our dead times are completed for our 161 firmware update. If we were doing a voltage pressure table, notice how the lowest row here is 43.5, and that row got updated from my curve. Okay, something important here: if you're not running a fuel pressure sensor for feedback and you use the voltage table, it is going to pull from this bottom row because you have no pressure input. So it's going to it's going to use a pressure value of 0. So if you want to fill your table out, okay, you're going to need to make sure that whatever pressure you're running is set to that lowest row, okay, which is obviously is not ideal. If you're using a returnless style fuel system, you absolutely need to be using a sensor for fuel pressure feedback. So I'm going to leave this on curve, and we're ready to go. All right, guys, that was updating the required fuel and your injector dead times when moving from 1.5 to 1.6 firmware. Now, I did an injector update during this process. Let me just cover real quick in the spreadsheet what you would do if you were just moving from 1.5 to 1.6 and not changing your injectors. So in this spreadsheet, and this is my spreadsheet, so you guys don't have all of these pages, but we've got this 1.5 firmware 1.5 calculator that's going to calculate for you if you've just got some basic injector settings. Here's the firmware update page, and this is when moving from 1.5 to 1.6. You're simply going to take your values directly out of your 1.5 tune, put them into the spreadsheet here up top, and then it will spit out values for you to input into 1.6. Okay, and here is a 1.6 fuel pressure table. You can basically take your values and populate this table if you've got everything in milliseconds, and it's going to calculate them in microseconds for the 1.6 firmware. This is pretty easy. You're just going to multiply milliseconds by 100 to get to the 1.6 value from milli to micro. I'm sorry, multiply by 1,000. All right, guys, now that we've got the required fuel and the injector dead times updated for the tune for 1.6, let's go ahead and start the car and see if those changes are appropriate and how close they are for the new 52-pound injectors. Now, I won't lie, the 19-pound injectors that were originally in this car, we tried really hard to get appropriate data for them because this is a mass air tune. But they're old injectors, and sometimes that data is really hard to come by. So some of it was best guess, and some of it was on our injector bench where we tested those dead times. Now, let's see how close we were and how close the Ford data is. All right, let's just verify the injector settings took. All right, and see if she starts. Give it a minute for the wideband to come up. It's not too bad. We're a little bit on the rich side. We're also not completely warmed up. that's not too bad. I would call that successful. We were able to update the settings and the vehicle started without issue on the first try. So if you guys have any other questions about updating your injector settings or otherwise, especially when it comes to required fuel or injectors in general, feel free to reach out and let us know. We'll do our best to collect that information for you and put it into a format that's easy to understand. Thanks for joining.